Okay, let's cut through all the noise. Today, we're not just going to look at the headlines. Nope, we are putting on our engineering goggles to see what's really going on under the hood. The talent wars, the hardware battles, and the models that are actually pushing the boundaries. Let's dive in.
Right? Because that's the real question if you're actually building this stuff. You have to look past the marketing and see the real strategic moves being made. So that's what we're going to do. We're going to connect the dots by looking at the three layers that matter most: the people, the silicon they're building on, and of course, the models themselves.
So first up, the people. It's easy to forget, but you can have all the data in the world, and it doesn't mean a thing without their brain power to make it work. And right now, the way top talent is bouncing between companies, well, it's telling us a whole lot about who's playing the long game.
And look, we're not just talking about hiring more software engineers. This is different. This is like a series of surgical strikes for the architects, the people who can literally build the foundations for the next decade of AI. A hire like this tells you everything you need to know about a company's real priorities.
Now, this slide is just fascinating because you're seeing two totally different philosophies at play. On one side, you've got Amazon snagging a top chip designer, Steve Mole, from Google. That's a huge flashing sign that they are going all in on owning their own hardware stack. Then on the other side, you have Microsoft offering buyouts, betting that its AI tools will make their existing teams so productive they won't need to grow. As an engineer, you have to ask yourself, which vision of the future do you bet your career on?
So all this top-tier talent, where are they going? Well, they're being pulled into one of the biggest arms races in tech history, the race to build custom silicon. This is where that talent shuffle we were just talking about has a direct impact on the hardware.
See, when you design your own chips, you control your own destiny. Think about it this way. Training a huge AI model is like sending it to college. It's incredibly expensive and it uses a ton of power. That's what Amazon's Trainium chips are built for. But inference? That's the model after college, out in the real world doing its job. It needs to be fast and super efficient. That's where Graviton comes in. Because it's ARM-based, it's way more power efficient, which saves a fortune at scale. Owning both gives you a massive, massive edge.
And this is where it all comes together. Meta just went out and bought millions of those super efficient Graviton chips from AWS. But here is the killer detail. Look at that strategic focus. AI agent workloads. They're not using these to train the next giant llama model. They're getting ready to deploy millions of small, fast, efficient AI agents. For any engineer watching this space, that's a huge tell. The industry is shifting from just training models to actually using them everywhere.
Okay, so we've got the people, we've got the hardware. Now let's move up the stack to the software that runs on top of it all, the models themselves. And the competition here is, well, it's absolutely ferocious, and the battle lines are being drawn in some really specific, really important areas.
Let's start with code generation, because honestly, for engineers, this is the holy grail. A model that can write clean code, find bugs, and this is the big one. Understand the context of a huge, messy code base. That's the ultimate productivity boost. Right now, it looks like Anthropic has a real edge, so much so that Google has apparently created a strike team just to catch up. This isn't just for fun demos. This is a war for the hearts and minds of developers.
And this race isn't just about text and code either. Take a look at Grok's new voice model. They're tackling something that is incredibly hard to get right: understanding complex, real-time conversations. This is way more than just turning speech to text. It's about figuring out context, dealing with latency, and understanding all the weird nuances of how people actually talk. These are massive engineering challenges.
And here's the thing, it's not a lab experiment. They're actually deploying it. This model is already handling customer support calls for Starlink, and it's hitting a 70% autonomous resolution rate. Forget about synthetic benchmarks for a second. That is a number that makes everyone in the industry sit up and take notice. It's real-world proof that it works.
Okay, all this technical progress is amazing, but it naturally leads to two really practical and really urgent questions. First, how are we going to pay for all this? And second, as this tech gets more and more powerful, who's actually in charge of setting the rules of the road? This is the question that moves AI from being a cool research project to being a real business. The cost to train and run these things is just astronomical. So the whole industry is now hyper-focused on finding business models that, actually work. And here's a perfect example of what that looks like. Anthropic is switching to usage-based pricing. Now, for a developer, this means your costs aren't some flat monthly fee anymore. They scale directly with how much your app gets used. That's great when you're just starting out, but it also means if you get a sudden spike in traffic, so does your bill.
It completely changes the economics and forces you to think about cost efficiency from day one.
And then you've got this question of who makes the rules. We always think it's going to be governments, but check this out. The Vatican is getting involved. The Pope literally told priests not to use AI for writing their sermons, but even bigger than that, they're working on their own state-level AI frameworks. It's this incredible move to assert moral authority in a world that's increasingly run by machines.
And that really brings us to the biggest, most important open question of all. From the talent to the hardware to the models themselves, the speed of innovation is it's mind-blowing. Engineers are focused on one thing, building what's possible as fast as humanly possible. So the critical question we all have to grapple with is this. While they're building the engines, who's responsible for building the guardrails?